Dmitri Mendeleev, the visionary scientist. A birth in the coldest reaches of the Russian Empire, in the frigid town of Tobolsk, located deep within Siberia, Dmitri Ivanovich Mendeleev was born on the 8th of February, 1834. The harsh, snow-laden environment into which he arrived seemed a world away from the grand cities of European science. Yet this remote town would be the unlikely cradle of one of the greatest scientific minds in human history. Mendeleev was the youngest of at least 14 children in his family. His father, Ivan Pavlovich Mendeleev, was a teacher of fine arts, politics, and philosophy. His mother, Maria Dmitrievna Kornilieva, came from a family of wealthy Siberian merchants. Though the family initially enjoyed some comfort, their fortunes began to shift tragically when Ivan lost his eyesight, rendering him unable to work. The responsibility of supporting the family then fell entirely upon Maria. Her strength was legendary. Refusing to allow hardship to dictate her children's fate, Maria reopened a long-abandoned glass factory inherited from her family and managed it with fierce determination. Her resilience and vision would leave an indelible mark on young Dmitri, who saw in her a model of unwavering commitment to purpose. It was from her that he inherited the twin fires of discipline and vision that would later guide his scientific pursuits. Mendeleev's early education was shaped by both curiosity and the stern necessity of survival. In Tobolsk, he enrolled in the local gymnasium, where he quickly exhibited remarkable intelligence, especially in mathematics and science. However, it was not until tragedy struck again that his future began to unfold. In 1847, when Dmitri was only 13, his father died. Soon after, the glass factory burned to the ground. Maria, now burdened with few options, decided to take her son across the vast expanse of Russian early 2,000 kilometers to Moscow in search of a better education. Denied admission at the university due to their provincial status, they pushed further to St. Petersburg. After months of hardship, in 1850, Mendeleev was finally accepted into the main pedagogical institute in St. Petersburg, a prestigious institution where teachers of Russia were trained. Though his health faltered, he would soon be diagnosed with tuberculosis. His intellectual fire burned brighter than ever. Despite illness and poverty, he graduated in 1855 with top honors. He was determined not merely to be a scholar, but a seeker of truth, one whose knowledge could reshape the scientific landscape. In the mid-19th century, science was undergoing a golden age of discovery. Electricity, magnetism, the nature of light and heat, and especially chemistry, were areas of exploding knowledge. Across Europe, scientists were beginning to realize that elements, the fundamental substances of matter, could be organized, though no one knew how or why. At this time, chemical elements were being discovered almost monthly, but there was no coherent system to organize them. The atomic weights of many were still disputed. The relationships between properties of different elements were unclear. Chemistry was a field rich with data, but poor in structure. Mendeleev, always attentive to systems and order, began to ask a radical question. Could there be a deeper law governing the behavior and arrangement of the elements? What if nature, in its complexity, followed a hidden but discoverable pattern? But before he would change the world, Mendeleev had to complete his training. For this, he needed to go west to Germany, the epicenter of chemical innovation. Heidelberg and the seeds of genius. In 1859, Mendeleev secured a government scholarship and traveled to Heidelberg, where some of the most advanced work in chemistry was taking place. There he studied under the towering figures of the time, Robert Bunsen and Gustav Kirchhoff. While in Heidelberg, Mendeleev attended the International Chemistry Congress in Karlsruhe in 1860, an event that would profoundly shape his destiny. At this Congress, Chemists from all over Europe debated how to standardize atomic weights and chemical formulas. One speaker, Italian chemist Stanislao Cannizzaro, presented a paper that argued persuasively for Avogadro's hypothesis that equal volumes of gases contain equal numbers of molecules. Mendeleev was deeply influenced by Cannizzaro's logic. He later wrote that it was this moment when he grasped how to apply atomic weights logically that planted the seed for what would become the periodic table. Though he could have remained in Germany, Mendeleev felt a duty to return to Russia. His homeland needed science, and he was prepared to be its emissary. Back in St. Petersburg, Mendeleev threw himself into work. He taught chemistry first at the Simferopol Gymnasium and later at the St. Petersburg Technological Institute and the University of St. Petersburg. He also began publishing academic papers and books, among them a 2-volume chemistry textbook that would become a cornerstone of scientific education in Russia. As he taught, he found it frustrating that the existing knowledge of chemical elements remained chaotic. The known elements, 63 at the time, seemed to behave according to patterns, but no one had clearly organized them. Various chemists had tried to group them Dobereiner's triads, Newland's law of octaves, and others, but none had successfully captured the full complexity of the element's properties. Mendeleev was determined to go further. He began assembling cards with information about each element's atomic weight, chemical behavior, density, and more, and laid them out like a deck on his desk, moving them around, trying to detect order. It is said that the idea came to him in a dreama moment of pure insight that would become one of the most famous breakthroughs in the history of science. In 1869, Mendeleev published his first version of what would be called the periodic table of elements. Unlike others, he arranged the elements not just by increasing atomic weight, but by grouping them according to their chemical properties. When the properties didn't match the order of atomic weights, he boldly reversed the sequence, arguing that the chemical behavior was more fundamental. More remarkably, Mendeleev left intentional gaps in his table. He predicted that elements yet undiscovered would fill those gaps and describe their properties in advance. He named 3 of these unknowns, Eka, aluminum, Eka boron, and Eka silicon, and confidently asserted that they would soon be found. His periodic law was a revelation that the properties of elements are a periodic function of their atomic weights. Nature, he had shown, was not random. It followed deep patterns. At first, the response from the scientific community was skeptical. Many chemists dismissed his table as speculative. Others questioned his audacity in adjusting atomic weights and predicting unknown elements. But Mendeleev was not a man easily discouraged. Between 1875 and 1886, his faith in the periodic law was spectacularly vindicated. The 3 missing elements he predicted, gallium, scandium, and germanium, were discovered, and their properties matched his forecasts with astonishing accuracy. The world took notice. The genius from Siberia had seen what others could not. His periodic table became the cornerstone of modern chemistry. Part 2. The Philosopher of Science. Mendeleev's vision beyond chemistry. Having revolutionized the field of chemistry with his periodic table, DMITRI MENDELEEV could have rested on his laurels, but his mind was never limited to a single discipline. He saw science as a unified endeavor. Chemistry, physics, geology, agriculture, and industry were all interconnected. To him, knowledge was not confined to categories. It was a vast, living system that demanded exploration from every angle. Mendeleev believed that science was not merely about acquiring data or making predictions. It was about understanding the deeper principles that govern the universe. This vision set him apart not just as a chemist, but as a philosopher of science, a thinker who asked not only what, but why and how. The power of patterns. Mendeleev's scientific worldview. Mendeleev was obsessed with order, but not with rigidity. He believed that beneath the apparent chaos of the natural world, there existed harmony, what he called periodicity. This conviction extended beyond chemical elements. He believed that the earth itself, its resources, its materials, and its climate patterns were governed by unseen laws waiting to be uncovered. His method was meticulous. He cataloged phenomena, sought relationships between seemingly unrelated data, and made bold inferences. This approach wasn't just analytical, it was almost poetic in its sensitivity to natural rhythms. He once said, "It is the function of science to discover the existence of a general reign of order in nature and to find the causes governing this order." These words reflected not only his scientific mission, but his lifelong commitment to the ideal of a rational, ordered universe. Education and the people. Mendeleev, the reformer. Mendeleev wasn't content to keep science locked away in laboratories or universities. He was a passionate advocate for education, especially public, practical education. He strongly believed that the Russian people needed access to scientific knowledge to improve their industries, agriculture, and overall well-being. He published simplified scientific articles for workers and farmers. He organized chemistry laboratories for students. He translated foreign scientific works into Russian. He gave public lectures. He even proposed massive reforms to Russia's educational system, arguing for the inclusion of natural sciences in standard curriculums. In his own words, "The scientific method must not remain a toy of the elite. It must serve the progress of the people." Mendeleev and the oil boom. A chemist in the age of industry. Long before petroleum became the dominant global fuel, Mendeleev recognized its transformative potential. In the 1860s and 70s, he traveled to the oil fields of the Caucasus, particularly Baku, to study oil extraction, distillation, and economic viability. In his extensive reports, Mendeleev analyzed oil chemistry, transportation logistics, environmental impact, and market economics. His famous proposal to transport oil using cars' large cylindrical tanks mounted on railways was revolutionary. It greatly improved the efficiency of petroleum distribution and laid the foundation for modern oil logistics. He also called for state-regulated oil refining, warning that unregulated industrial practices could lead to economic monopolies and environmental disasters. In this, he was decades ahead of his time. Mendeleev's oil research earned him the title, "the father of Russian petroleum science." Innovation across boundaries. Explosives, naval science, and agriculture. Mendeleev's scientific curiosity knew no limits. In addition to chemistry and petroleum, he contributed to a staggering range of fields, explosives and propellants. He researched nitroglycerin and gunpowder for military applications, aiming to improve safety and reliability in Russian arsenals. Naval engineering. He developed improved formulas for smokeless gunpowder and helped modernize Russia's navy with better fuels and materials. Agriculture. He applied chemical principles to soil analysis and fertilizer development, advocating for more scientifically informed farming techniques. Meteorology. He founded a weather observatory and conducted atmospheric studies, contributing to early Russian climatology. His interdisciplinary work reflected his belief that science must serve national development not just through discovery, but through application. Mendeleev, the economist. Numbers and national strategy. Perhaps most surprisingly, Mendeleev was also an economist. He published major works on tariff policy, industrialization, and population growth. He used data-driven models to predict Russia's economic future and advocated for policies that would develop its domestic industries. His magnum opus in this area, Toward Knowledge of Russia, was a socio-economic analysis that combined statistics, science, and philosophy. In it, he argued that Russia needed not only technological advancement, but a cultural transformation toward rationality, education, and scientific thinking. He wrote, "Without science, there is no wealth. Without wealth, there is no freedom." This vision placed him among Russia's most progressive intellectuals, people who saw knowledge as the true engine of civilization. Challenges and isolation. Enemies in high places. Despite his achievements, Mendeleev was not universally celebrated during his lifetime. In fact, he was often met with jealousy, suspicion, and institutional resistance. His ideas, especially his reformist political stances, brought him into conflict with conservative factions in the Russian Academy of Sciences. In 1880, Mendeleev was nominated for a full seat in the Academy. Shockingly, he was rejected, move that outraged many Russian scientists and intellectuals. Some historians believe it was due to his controversial support for liberal reforms and his challenge to academic elitism. Mendeleev, however, remained unbitter. He simply turned his energy elsewhere toward writing, teaching, and public service. Honors and global recognition. While Russia's scientific establishment sometimes resisted him, the international community embraced Mendeleev. He received awards and honorary doctorates from universities in Germany, France, Great Britain, and the United States. He was celebrated by the Royal Society of London, the French Academy of Sciences, and even the Nobel Committee, though politics prevented him from receiving the Nobel Prize. In 1905, the British Royal Society awarded him the Copley Medal, their highest honor, calling him the greatest of the chemical discoverers since Lavoisier. He once remarked, "If truth is universal, then science belongs to all nations." Personal life. Marriage, controversy, and family. Mendeleev's personal life was as dramatic as his intellectual one. He was married twice, first to Feozva Leshcheva, a union arranged by family that proved unhappy. In 1882, while still technically married, he fell in love with a much younger woman, Anna Popova. They married after a controversial divorce which shocked Russian society. Despite social backlash, the marriage to Anna was joyful and productive. They had 4 children, and Mendeleev found peace in domestic life, even as his public career remained turbulent. He loved art, music, and travel. He was also known for his eccentric habits, such as carrying a barometer during train rides to measure altitude changes. His home was filled with instruments, maps, and scientific curiosities. Mendeleev's vision for the future. In the final decades of his life, Mendeleev became increasingly interested in the philosophy of science. He wrote essays contemplating the unity of the cosmos, the purpose of human knowledge, and the relationship between science and spirituality. He predicted that chemistry would merge with physics and lead to astonishing discoveries. He even speculated on the existence of elements beyond uranium, a prediction later confirmed with the discovery of transuranic elements. His last works were meditations on knowledge itself. In them, he argued that science must remain open, honest, and grounded in empirical reality, but always guided by imagination and ethical responsibility. Part 3. The Legacy That Shaped the World. Final years. A scientist's race against time. In the early 20th century, as Russia stood on the brink of revolution, Dmitri Mendeleev was still at work. Even as his hair turned white and his steps slowed, his mind remained unrelenting. He occupied a prominent role at the Bureau of Weights and Measures, modernizing Russia's standards of mass and measurement to align with the emerging international metric system. He gave interviews, wrote philosophical essays, and revised his earlier scientific papers with painstaking care. But there was also a sense that he was in a race not against other scientists, but against time itself. He knew the world of science was accelerating, and he wanted to leave behind a complete, enduring legacy. In 1906, after several months of declining health, DMITRI MENDELEEV was diagnosed with severe pneumonia. As he lay in his bed, he continued to dictate thoughts to his assistants, scribbling ideas onto scraps of paper. On the 2nd of February, 1907, just days before his 73rd birthday, Mendeleev died in St. Petersburg. His final words, reportedly spoken in a whisper, were, "It is all organized. All follows from order. Funeral and public mourning. Russia bids farewell." Mendeleev's funeral was a national event. Thousands of mourner students, fellow scientists, workers, and farmers lined the streets of St. Petersburg. His coffin was draped in the colors of the Russian flag, and the hymns sung at his memorial echoed with the lines, "The world honors your mind and your heart." Though once rejected by the Academy of Sciences, in death he was celebrated as a national treasure. Newspapers from Moscow to Paris ran obituaries praising him as the Newton of the North and Russia's prophet of science. At the St. Petersburg University, where he had taught for decades, his laboratory was preserved as a shrine to his legacy. His books, glassware, instruments, and handwritten notes were placed behind Glass Museum of Genius. The periodic table evolves from order to atom. In the decades following Mendeleev's death, science moved swiftly. One of the most astonishing developments came in 1913 when the British physicist Henry Moseley discovered that atomic number knot, atomic weight, was the true basis of periodicity. This confirmed what Mendeleev had intuited, but lacked the tools to prove. Mendeleev's table had used atomic weights to organize elements. Moseley showed that it was really the number of protons in the nucleus that determined each element's position in the periodic system. The periodic law was thus reformulated to state the properties of elements are periodic functions of their atomic numbers. With this discovery, the modern periodic table of the elements, a direct descendant of Mendeleev's, was born. It remains the backbone of chemistry today. The rise of nuclear chemistry and new elements. In the 20th century, as chemists and physicists delved into radioactivity and nuclear science, they began discovering elements far beyond what Mendeleev had known, elements with atomic numbers higher than 92 uranium. These synthetic elements were created in particle accelerators and nuclear reactors. One of the most dramatic acknowledgments of Mendeleev's contribution came in 1955, when scientists at the University of California, Berkeley, synthesized a new element 101. They named it Mendeleevium. For the first time in history, the name of a scientist was permanently etched into the periodic tableau as a footnote, but as a fundamental part of nature's order. His ideas in the classroom, the universal language of chemistry. Across the world, Mendeleev's periodic table became one of the most recognized symbols in science. It is taught in every high school chemistry class, referenced in university research labs, and displayed in posters, textbooks, and scientific literature. What makes it extraordinary is its universal language. It speaks across nations, across time, and across cultures. Whether in Tokyo or Buenos Aires, Nairobi or New York, students see the same table, understand the same logic, and trace it all back to the mind of a Siberian boy who dared to search for order in chaos. No other scientific diagram, not even Newton's laws or Darwin's evolutionary tree, has had such a consistent and global presence. The scientific spirit. Lessons from Mendeleev. Mendeleev's legacy is not just his discoveries, but his scientific spirit. He embodied a unique blend of skepticism and imagination, tradition and rebellion, order and daring. He taught us to look for patterns even when the data is incomplete, to trust logic but never fear revising it in light of new evidence, to embrace complexity, not avoid it, to predict boldly but ground every prediction in evidence, and above all, to believe that nature follows laws even if we haven't yet discovered them. In a time when science can seem disconnected from the public or mired in controversy, Mendeleev stands as a reminder that knowledge, when sought with honesty and courage, elevates us all. Beyond chemistry, a philosopher in a lab coat. Many of Mendeleev's writings reveal a profound philosophical streak. He contemplated not only the behavior of atoms, but the structure of knowledge, the ethics of discovery, and the destiny of humankind. He warned against pseudoscience, blind faith, and untested dogma. Yet he also believed that science should not become a cold, mechanical enterprise. It must be inspired by wonder and driven by purpose. One of his favorite maxims was, "Science is but a means to an end, the end being the happiness and progress of mankind." He believed in a world where science and morality could coexist, where knowledge could be harnessed not for conquest, but for compassion, where the pursuit of truth could uplift the human soul. A legacy engraved in the elements. More than a century after his death, DMITRI MENDELEEV continues to shape the world. His name lives on not just in element 101, but in scientific institutions, schools, awards, and even space. An asteroid and a lunar crater are named after him. In Russia, he is celebrated as a national hero. His face has appeared on currency. His quotes are etched in marble in university halls. His statue stands tall at St. Petersburg University, where his hands rest upon a periodic table carved in stone. And, across the world, every time a chemist arranges elements, calculates molecular weights, or discovers a new compound, they are, in a sense, walking in Mendeleev's footsteps. Closing reflections. The man who ordered the universe. From the icy streets of Tobolsk to the scientific halls of Europe, from poverty to worldwide renown, from forgotten glass factories to the stars above, DMITRI MENDELEEV's journey is the story of science itself. He proved that even in disorder we can find harmony, that even in mystery we can trace meaning. That knowledge is not static, but growing, reaching, dreaming, just like he did. He was more than a chemist. He was an architect of understanding, a visionary of laws, and a builder of the bridge between man and matter. DMITRI MENDELEEV showed us how to read the universe. Part 4. Mendeleev's Hidden Chapters. Unfinished work, unseen writings, and the soul of a scientist. Notebooks in the shadows. What Mendeleev left behind. When DMITRI MENDELEEV died in 1907, he left behind more than the periodic table. He also left a treasure trove of unpublished manuscripts, notebooks, and philosophical essays, some incomplete, others so advanced that even his contemporaries struggled to understand them. These notes, written in a mix of Russian, French, and scientific shorthand, covered a startling range of topics. The mathematical structure of chemical bonding, the possibility of elements beyond the known universe, notes on time, space, and the nature of consciousness, reflections on the limitations of human understanding, locked away for decades in university archives. Many of these writings weren't fully examined until the late 20th century. Modern historians of science now see them as evidence that Mendeleev was not just a chemist, but a visionary thinker ahead of his time, someone whose ideas reached into the philosophical, even the metaphysical. Chemistry and Cosmos, Mendeleev's Cosmic Order. One of the most fascinating documents among his papers is a collection titled The Universal Law of Matter. In it, Mendeleev proposed a unified vision of the universe-sun where matter, energy, and space all followed a great unseen periodicity similar to what he had found in chemistry. He speculated about a universal periodic law extending beyond Earth, the existence of a deeper, undiscovered structure behind the elements, a possible fifth state of matter under extreme conditions, something modern physicists now study under quantum condensates. While many of these thoughts were more philosophical than empirical, they showed Mendeleev's bold intellectual reach. He saw the periodic table not as an end, but as a door to something greater, a cosmic language of harmony. God, faith, and scientific rationality. Mendeleev was born into the Russian Orthodox tradition, but his relationship with religion was complex. Unlike many 19th century scientists who rejected religion outright, Mendeleev sought a middle path, a synthesis of faith and reason. He believed that science revealed the order and majesty of the universe and, by extension, hinted at a higher intelligence behind it. However, he opposed superstition and blind faith, calling for beliefs to be compatible with evidence and logic. In his essays he wrote, "I do not deny God, but I deny the idea of God as a magician. God is the laws of the universe, the cause and the reason of all that is." This pantheistic view, similar to those of Spinoza and Einstein, saw divinity not as a person, but as the totality of natural law. For Mendeleev, the periodic table itself was a sacred architectural revelation of the divine in the fabric of matter, the dream of a universal science. In one of his lesser-known projects, Mendeleev envisioned a massive encyclopedic work that would unite all branches of science. He called it The General Outline of Natural Knowledge, a book that would explain everything from atomic theory to cosmology to the human mind in one structured system. He began drafting outlines for this masterwork in the 1880s, but his duties as an educator, government official, and industrial advisor prevented its completion. Still, fragments survive dozens of pages of carefully written outlines, diagrams of interrelated laws, and philosophical notes that prefigured the idea of systems theory and interdisciplinary science concepts that would only become prominent in the 20th century. He imagined a future where chemistry would merge with biology through molecular theory, physics would explain consciousness through thermodynamics, engineering would be guided by ecological ethics. In many ways, he foresaw the very fields we now call biochemistry, quantum biology, systems ecology, and AI-driven science. Mendeleev and the unknown, paranormal curiosity, or scientific courage. Surprisingly, Mendeleev occasionally investigated claims that would today be considered fringe science. This included topics like alchemical transformation in the context of understanding transmutation, mind-matter interaction, early questions of consciousness and physics, human intuition as a form of pattern recognition, but his approach was never mystical. He always emphasized skepticism and the need for evidence. He kept detailed files on these subjects not because he believed in the supernatural, but because he refused to rule anything out without investigation. For Mendeleev, true science meant never fearing the unknown even when it seemed irrational. He wrote, "To call something impossible is to close the book before reading the final page." This mindset made him unique among his peers. He had both the discipline to organize truth and the courage to chase mystery. The Mendeleev Code, Mathematical Structures in Nature. Some of Mendeleev's most cryptic writings relate to mathematical sequences in the periodic system. He hypothesized that elements could be grouped not just chemically, but numerically based on harmonic patterns, ratios, and frequencies. Modern researchers studying his notebooks believe he may have been inching toward what we now call quantum number theory. He seemed obsessed with hidden periodicities patterns within patterns. He even tried, unsuccessfully, to derive a mathematical formula for predicting not just the properties of undiscovered elements, but the emergence of life-essential compounds. While these efforts never matured into formal theories, they hint at a remarkable idea that Mendeleev believed mathematics could describe not just matter, but meaning. The personal writings, Doubt, Hope, and Legacy. Among his final journals, Mendeleev expressed concern about the direction of science. He worried that rising nationalism, commercialism, and dogmatic thinking would corrupt the pursuit of knowledge. He wrote, "Science must not become the servant of empires, nor the weapon of ideologies. It must remain free like truth itself. He also lamented that many scientists no longer questioned the foundations of their disciplines, but merely repeated what came before. And yet, he remained hopeful. The laws of nature are not exhausted. The future will see what we have only glimpsed. These private writings show a man deeply aware of his place in history, yet also painfully aware of what was left unfinished. Rediscovering Mendeleev in the 21st century. Today, scholars, chemists, and philosophers alike are revisiting Mendeleev's work not just for historical insight, but for inspiration. His efforts to unify knowledge, his respect for both logic and mystery, and his fearless thinking are increasingly seen as models for modern interdisciplinarity. Institutes around the world have digitized his archives. His personal letters are studied for insight into the nature of creativity, and his dreams of a unified science are echoed in global efforts to integrate physics, chemistry, biology, and consciousness studies. Mendeleev is no longer just the father of the periodic table. He is being reimagined as a prophet of scientific wholeness, a man who saw not just atoms, but systems, not just facts, but futures. Part 5. The Immortal Mind of Mendeleev. How his vision continues to shape our world and beyond. The periodic table today, a living testament. Over a century after its creation, the periodic table of elements remains one of the most iconic structures in science. But it has not remained static. As new elements are synthesized and atomic theories evolve, the table continues to expand just as Mendeleev predicted. Modern versions of the table reflect the quantum structure of atoms, organizing elements not just by atomic weight or number, but by electron configuration, shell structures, and chemical behaviors. And yet, despite these refinements, the skeleton of Mendeleev's original design is still visible. His ideas were not just correct, they were foundational. He uncovered a framework so natural, so universal, that even today's discoveries must conform to its logic. It is not an overstatement to say every scientific breakthrough in chemistry still bows to the mind of Mendeleev. Mendeleev, in modern research and technology, the disciplines Mendeleev influenced now extend far beyond chemistry. In the 21st century, his legacy is found in areas he could never have imagined. Materials science. Researchers use the periodic table to design custom alloys, nanomaterials, and superconductors. Pharmaceuticals. Drug discovery algorithms rely on chemical families and periodic trends, first articulated by Mendeleev. Energy storage. Lithium, cobalt, and other rare earth elements now essential in batteries and electric vehicle SARE, chosen using periodic logic. Environmental science, toxicology, pollution control, and sustainable chemistry all depend on understanding periodic groupings. In essence, Mendeleev's structure is now a universal coding system for matter, deeply embedded in the algorithms, databases, and decision engines that drive modern science. In the classroom, the first scientific alphabet. For millions of students, the periodic table is their first exposure to the logic of science. Hung above chalkboards, printed on notebooks, and memorized through rhymes, the table has become what some educators call the scientific alphabet. It teaches not just chemistry, but classification, abstraction, and reasoning. Students learn why elements group together, how atomic numbers rise in steady rhythm, what patterns emerge from nature's design. This is Mendeleev's gift to education, a tool that introduces children to the concept that the universe is knowable, organized, and waiting to be understood. Mendeleev's face on currency and stamps, the world has not forgotten him. In Russia, Mendeleev's portrait has appeared on ruble banknotes and postage stamps. In Europe and Asia, science-themed currencies and memorabilia often bear his image beside the periodic table. The United Nations Educational, Scientific, and Cultural Organization, UNESCO, declared 2019 the International Year of the Periodic Table, honoring the 150th anniversary of Mendeleev's discovery. During the celebration, global scientists declared, "This is not just Mendeleev's achievement, this is humanity's shared scientific heritage. In outer space, Mendeleev among the stars, even beyond Earth, Mendeleev's name travels. A crater on the moon, located on its far side, is named Mendeleev Crater. An asteroid 2769 Mendeleev orbits between Mars and Jupiter. NASA's planetary science missions have used elemental spectroscopy based on periodic principles to decode the atmospheres of Venus, Mars, and Titan. These celestial honors are fitting. Mendeleev saw chemistry as the language of the cosmos, and now his name is etched into the heavens themselves. International scientific institutions bearing his name. Around the world, dozens of institutions now carry his legacy. The DMITRI University of Chemical Technology of Russia, Mendeleev Institutes in Ukraine, Kazakhstan, and Bulgaria. Global chemistry awards named in his honor, including the Mendeleev Medal, the Mendeleev Prize in Chemical Innovation, the Mendeleev Lectureships hosted annually in scientific congresses. These institutions continue to train the next generation of researchers, not just in chemistry, but in Mendeleev's multidisciplinary spirit. Popular culture and artistic tributes. Beyond laboratories and classrooms, Mendeleev has become a cultural symbol of genius. Films, documentaries, and animated shorts recount his dramatic life story. His face appears in murals, sculpture parks, and even comic books. Musicians have composed symphonies based on chemical periodicity, naming movements after elements. In Moscow, a theater group once staged a biographical play about his glass factory childhood titled Table of Fire. Mendeleev, once a boy from Siberia, is now a universal archetype, the lonely genius who saw order in chaos. Ethics, ecology, and the future of science. One of the most overlooked aspects of Mendeleev's legacy is his ethical philosophy of science. He believed deeply that scientific knowledge must serve the environment, public health, economic justice, peaceful collaboration. He warned about pollution from oil refining, advocated for agricultural sustainability, and denounced the use of science for imperial conquest. In the 21st century, as we face climate change, ecological collapse, and artificial intelligence dilemmas, Mendeleev's voice echoes back to us. Science is powerful only when guided by conscience. This moral framework may be his most urgent gift to our era. Children of the periodic table, Mendeleev's descendants. Every modern chemist, biologist, physicist, and computer scientist carries part of Mendeleev's DNA, not biologically, but intellectually. The design of semiconductors relies on group properties of elements. The logic of machine learning mirrors the pattern-finding Mendeleev pioneered. The hunt for exotic materials and super-heavy elements continues where his predictions ended. In this sense, we are all children of the table scientific descendants of a man who wrote the alphabet of the elements and invited the world to speak its language, the mind that will never die. In the final analysis, DMITRI MENDELEEV was not merely a historical figure. He wasn't Isa's structure of thought. Wherever order is found in data, wherever new elements are explored, wherever teachers light a fire in young minds using periodic principles, Mendeleev lives. His life proved that vision matters, that hard work, even in isolation, can change the universe, that ideas born in obscurity can outshine centuries of tradition. He was the boy who dreamed in patterns, the man who mapped the invisible, the scientist who touched the infinite. DMITRI MENDELEEV, chemist, philosopher, visionarius, immortal. Part 6. Inside the Mind. 10 lesser-known experiments and theories of DMITRI MENDELEEV. While DMITRI MENDELEEV is universally celebrated for the periodic table, Much of his scientific curiosity and experimentation remains buried beneath this towering achievement. Yet his notebooks and writings reveal a brilliant polymath whose work spanned physics, agriculture, metrology, meteorology, and even psychological theory. This chapter explores 10 of Mendeleev's lesser-known scientific exploration ideas that were radical for his time, some validated much later, and others still awaiting discovery. Mendeleev's airship, the floating laboratory. In the 1880s, Mendeleev became fascinated with meteorology and atmospheric studies. He designed and built a hot air balloon to conduct upper atmosphere research. What made his mission remarkable was that he insisted on flying alone without prior piloting experience. In 1887, he ascended to over 11,000 feet during a solar eclipse to measure atmospheric composition and solar radiation. This made Mendeleev one of the first scientist aeronauts in history. Though lacking today's precision tools, his balloon records contributed to early understanding of atmospheric stratification and pressure gradients data that helped shape modern climatology. The search for a universal solvent. Long before nanotechnology and synthetic biology, Mendeleev theorized the possibility of a universal solvent, a substance capable of dissolving every other known material under specific conditions. Inspired by ancient alchemical texts, he hypothesized that under certain pressure and temperature combinations, supercritical fluids might mimic this behavior. He experimented with superheated water and alcohol mixtures, measuring how solubility changed with temperature. Though he never found the solvent itself, his findings prefigured the modern use of supercritical CO2s in industrial application. Alcohol and water, the hidden mystery of volume shrinkage. One of Mendeleev's strangest obsessions was the unusual behavior of alcohol and water when mixed. He noticed that mixing pure ethanol with water at a 1-to-1 ratio caused a reduction in total volume-modulating expected additive laws. This puzzled him deeply. He spent months conducting experiments and theorized that molecular interlocking was responsible, with ethanol molecules nesting between water molecules in a temporary bond structure. His 1,865 paper on alcohol-water contraction became the scientific basis for the 40% alcohol standard in vodka production. Later, studies of hydrogen bonding in liquid mixtures, Mendeleev's table of weights and measures. In 1890, Mendeleev was appointed director of the Bureau of Weights and Measures in Russia. He embarked on a national mission to standardize mass, length, volume, and temperature across the empire. He traveled extensively, comparing Russian units to the emerging metric system of Europe. Mendeleev insisted that scientific accuracy was a foundation of civilization, and that without universal standards, Russia would fall behind. His efforts helped modernize Russian industry and education. He also designed his own measuring instruments, some of which are still preserved in Russian scientific museum. The ether question. Mendeleev's 64th element. Though the concept of the luminiferous ether has long been discredited, Mendeleev took it seriously. He hypothesized that an undiscovered element might account for the transmission of light through space. He predicted an ultralight, inert gas with an atomic weight below hydrogen and placed it in the zero group of his periodic table. This 64th element, which he called newtonium in some private writings, never materialized. But his theory prompted the future discovery of noble gases like helium and neon. Though wrong about ether, his method of predicting unknowns by logical gaps would later prove revolutionary. The periodicity of the stars. Fascinated by astronomy, Mendeleev believed that elements in distant stars would follow the same periodic laws found on Earth. He corresponded with Russian and French astronomers, arguing that spectral lines from stars proved chemical universality. He speculated that the cosmos was governed by the periodic law, just as Earth was. This belief was later confirmed by spectroscopy, which revealed that stars across the universe share the same basic element, hydrogen, helium, carbon, etc. Mendeleev, without modern telescopes, had simply reasoned, nature has no provinces, it is one. Psychology and the structure of intuition. In a little-known manuscript dated 1898, Mendeleev explored human intuition and creativity, proposing that the mind operated on periodic cycles of insight. He compared the organization of ideas in the brain to the grouping of elements each thought linked by associations, memory, and emotional charge. Though primitive by today's cognitive science standards, his writing anticipated the connectionist model of thought, periodic shifts in creative productivity. The role of structure in insight generation. To Mendeleev, even thinking followed laws just as matter did. The periodic law and musical harmony. In a surprising experiment, Mendeleev tried mapping the periodic table to musical notes. He noticed that elements in similar groups resonated like octaves. Periodic increases in atomic weight mirrored the rise in pitch. Noble gases behaved like rest notes, or chords resolving tension. He built a rudimentary elemental organ, a musical keyboard labeled with element symbols, and assigned tones to their positions. Though this was more playful than scientific, it revealed his deep aesthetic sense of periodicity and attempt to bridge science and art. The fire triangle, combustion chemistry. Well before modern fire science, Mendeleev developed early theories of combustion, focusing on the balance between fuel, carbon compounds, oxygen, oxidizers, heat, activation energy. His diagrams of the fire triangle helped improve safety standards in factories and mines. He advised on fire-resistant materials and explosion prevention protocols. He even wrote a manual for Russian firefighters and miners, showing that he cared not only about theory but also about lives. Artificial transmutation, a forbidden dream. Though best known for his commitment to chemical order, Mendeleev was fascinated by the possibility of changing one element into another, an old alchemical dream. He speculated that under extreme pressure and temperature, atomic nuclei might be forced to transform. Of course, nuclear physics was not yet born, but his intuition laid the groundwork for the eventual development of nuclear fission, particle accelerators, synthesis of transuranic elements. He never succeeded in his own lab, but believed that the laws of transformation existed, waiting to be understood. Conclusion: the eternal experimentalist. Dmitri Mendeleev was not content to sit on a single discovery. His mind roamed freely across the realms of physics, psychology, music, agriculture, astronomy, and beyond. He was not just the architect of the periodic table. He was a restless explorer of hidden harmonies in nature, a man for whom no boundary, disciplinary, geographic, or intellectual was sacred. His lesser-known experiments reveal not just a scientist, but a seeker. Perceptini, the man behind the genius. A human portrait of Dmitri Mendeleev. Habits, love, and legacy at home. A man of fire. First impressions and physical presence. Descriptions of Dmitri Mendeleev by his contemporaries were often vivid and colorful. He was tall, broad-shouldered, with intense eyes that burned with focus. His thick beard and long hair gave him the look of a prophet or a wild mystic. But beneath the appearance of eccentricity was a razor-sharp intellect, methodical in practice and powerful in debate. He moved quickly when inspired, scribbling notes, sketching chemical structures, or rearranging periodic cards across his desk with visible intensity. Many colleagues were both inspired and intimidated by him. He had what some called scientific charisma, the glass factory boy. How his youth shaped his mind. Mendeleev often referred to his early years at his mother's glass factory as the true beginning of his education. There, surrounded by furnaces, flames, fragile materials, and the transformation of matter, he first became captivated by chemistry not in books, but in motion. He later wrote, "Fire is the oldest chemist. I merely followed its teaching." The daily observation of sand melting into glass, of color changing with temperature, of gases escaping in silence, these experiences grounded his scientific mind in the tangible, the sensory, the beautiful. This early environment also nurtured a lifelong appreciation for artisanship and for the human side of science. Love and turmoil, his first marriage. Mendeleev married Feozva Nikitichna Leshcheva in 1862, a union arranged largely through social expectation rather than love. The marriage was strained almost from the start. Feozva was quiet and conservative, while Mendeleev was bold, restless, and consumed by his work. As his career rose, so did tensions at home. He often stayed late at the university or laboratory, and when home, he was mentally distant. Their conversations were brief, strained, or overshadowed by his overwhelming focus on science. They had 2 children, but the marriage dissolved emotionally long before it ended legally. A scandal and a second love, Anna Popova. In the 1870s, Mendeleev met Anna Ivanovna Popova, a gifted art student nearly 30 years younger than he. She was vivacious, intellectually curious, and deeply intrigued by Mendeleev's mind. They began a passionate relationship while he was still married, a scandal that shook Russian society. When he divorced Feozva and married Anna in 1882, public backlash was swift and harsh. Church authorities refused to recognize the second marriage because the divorce had not followed canonical timelines. Mendeleev's critics used this scandal to argue against his appointment to high academic posts. But the marriage to Anna was a source of emotional revival. They had 4 children together and remained close until his death. She inspired his late-life interest in music, literature, and philosophy. Family life and fatherhood. Despite his intense schedule, Mendeleev cherished his children. He taught them scientific concepts, from a young Aga-turning kitchen experiments into lessons, explaining the stars during walks, and writing simple poems about the natural world. He believed that learning should be joyful and curiosity should be praised. He once said, "A child's question contains more wisdom than a teacher's answer." At home, he was known for his warmth, humor, and surprising tenderness. He played chess with his sons and carved toys with his daughters. Family dinners often turned into impromptu lessons on atoms, weather, or morality. Daily habits. A man of order and oddity. Mendeleev's daily routine was famously unusual. He worked in long bursts, sometimes 18 hours straight, then would sleep for nearly a day. He kept notebooks by his bed to record dream insights. He walked every morning with a barometer to track atmospheric changes. He wore his lab coat nearly everywhere, even while dining. He had a lifelong obsession with suitcases, reportedly designing a chemical-resistant traveling trunk that could withstand harsh weather and acid spills. Despite his eccentricities, his self-discipline was legendary. He balanced family life, public service, and scientific innovation with remarkable focus. Friendships and intellectual circles. Mendeleev maintained a wide circle of friends, including writers, painters, engineers, philosophers, and statesmen. He was close to Leo Tolstoy, with whom he corresponded about education and ethics, Ilya Repin, the painter who created his famous portrait, Alexander Butlerov, a chemist who helped modernize Russian chemical education, Nikolai Lobachevsky, whose work on non-Euclidean geometry inspired Mendeleev's thinking about structure and abstraction. These relationships sustained him intellectually and emotionally. He believed that science thrived on conversation, not isolation, enemies, rivals, and academic politics. For all his brilliance, Mendeleev was not always easy to work with. His directness, Impatience for bureaucracy and bold criticisms earned him many rivals and enemies, especially within conservative academic circles. Some professors saw him as arrogant, others feared his reformist politics. His failed election to the Russian Academy of Sciences in 1880 was partly due to these tensions. Mendeleev, for his part, disdained intellectual snobbery, once writing, "Knowledge should elevate the pioplanet, isolate the elite." Despite exclusion from some elite institutions, his reputation only grew with time, especially internationally. A love of nature and art. When not working, Mendeleev retreated to his country estate where he tended gardens, observed the stars, sketched trees and animals in his journals, played the cello, often late into the night. He believed that science and art were siblings, both born from the desire to understand beauty. His favorite composers included Beethoven and Tchaikovsky. His favorite painters were Dutch realists, whose work he admired for their attention to light and form. He once said, "To see order in nature is to see God's hand not in miracles, but in simplicity, the last days and reflections of a life fully lived." In his final years, Mendeleev's pace slowed, but his mind remained agile. He wrote poetry, compiled personal letters, and worked on a book that would never be finished, on the destiny of man and matter. He became more reflective, less combative, and more philosophical. One of his last writings read, "I have tried not to discover laws, but to listen to them. The universe whispers. We must only become quiet enough to hear." Surrounded by family, students, and loyal friends, he passed away peacefully in 1907. His final days were filled with reading, conversation, and handwritten reflections on the unity of all knowledge. Conclusion: not just a mind, but a soul. Dmitri Mendeleev was not a cold scientific instrument. He was a father, a lover, a teacher, a fighter, a poet. He lived fully, loved fiercely, and never allowed success to silence his principles. The man behind the genius was human, flawed, passionate, and eternal proof that science is not just about equations and discoveries, but about the person who dares to ask why. Part 8. Global Impact. How Mendeleev's vision influenced generations of scientists and breakthroughs across disciplines. The Global Table, a universal language of science. The periodic table, born in a Russian laboratory in 1869, has become the most universal scientific tool in history. From primary schools in Brazil to nuclear labs in South Korea, from medicine in Canada to material science in India, the table hangs on walls, prints on lab benches, and lives in every chemistry textbook. This global presence isn't accidental. It exists because of one man's logic and foresight, Mendeleev's realization that chemical properties followed a hidden, universal law. "Elements are not random," he wrote. "They are nature's alphabet." Influence on Marie Curie and the age of radioactivity. In the early 20th century, the world of chemistry was rocked by discoveries of radioactive elements, polonium, radium, thorium, and more. Marie Curie, whose work on radioactivity earned her 2 Nobel Prizes, often referenced Mendeleev's periodic system as a foundation for her experiment. Though radioactive elements didn't fit neatly into the known periodic groups at first, Curie saw the power of prediction in Mendeleev's model. His structure gave her and others a roadmap for seeking the unknown. The periodic law helped clarify atomic decay chains and anticipated new element behavior. Einstein and Mendeleev, 2 architects of order. Albert Einstein and Dmitri Mendeleev never met, but their intellectual frameworks were complementary. Mendeleev brought order to matter. Einstein brought order to energy and motion. Einstein once praised the periodic table for proving that the universe was intelligible and structured, and even cited it in conversations about the unity of physical law. While Mendeleev worked with macroscopic chemical properties, Einstein helped reveal the subatomic rules that confirmed periodic behavior, linking the elements to the quantum realm. Linus Pauling, chemistry's modern architect. Linus Pauling, one of the most influential chemists of the 20th century, described the periodic table as the greatest scientific achievement of the 19th century. Pauling's groundbreaking work on chemical bonding, molecular structure, electronegativity was deeply rooted in Mendeleev's system. Pauling built mathematical relationships upon the groups Mendeleev created. His discovery that chemical bonds and behavior could be predicted using quantum mechanics was a direct continuation of Mendeleev's vision translating observation into precision. The Manhattan Project and elemental engineering. During World War II, the race to build an atomic bomb known as the Manhattan Project relied on deep knowledge of the periodic table. Uranium and plutonium were chosen for their properties on Mendeleev's table. Elemental behavior guided bomb design and shielding. The discovery of transuranic elements beyond uranium, like neptunium and americium, came from studying gaps and trends Mendeleev first predicted. Ironically, a man who opposed war's destruction enabled, through his work, the tools of mass destruction, yet it was his method, not his intent, that guided them. Modern quantum chemistry, filling the table's foundations. Quantum mechanics, born in the 20th century, finally gave the why behind Mendeleev's what. Electron orbitals, energy levels, and quantum numbers explained why elements appeared in periodic patterns. Chemists discovered that atoms behave periodically due to electron shell configurations, the exact thing Mendeleev had suspected but couldn't prove. Thus, Mendeleev's table became not only accurate, it became inevitable, a reflection of deeper quantum law. His empirical order was revealed to be a mirror of the architecture of the atom. Influence on environmental science and green chemistry. Mendeleev's belief in harmony with nature resonates in today's ecological sciences. His system is now used to track environmental pollutants across elements, design biodegradable materials, develop non-toxic alternatives to harmful compounds, understand how heavy metals accumulate in living organisms. Scientists working on green chemistry and climate resilience use periodic trends to find safer, more sustainable materials. What began as a map of elements has become a guide to preserving Earth. Periodicity in biology. From the table to the cell. Surprisingly, the periodic table also underpins modern biology. The role of transition metals, like iron, zinc, and copper, in enzyme function, the classification of essential trace elements, DNA structures' dependence on phosphorus and nitrogen, even the origin of life theories explore how early Earth's elements, as grouped by Mendeleev, made certain molecules possible. In this sense, Mendeleev's periodicity didn't just describe matter, it described life itself. Space exploration and elemental discovery. In the 21st century, missions like NASA's Perseverance rover on Mars, ESA's Rosetta probe, and Japan's Hayabusa asteroid mission rely on elemental spectrometry guided by the periodic table. Astronomers use periodic logic to identify elements in distant stars, analyze the composition of planetary atmospheres, predict material behavior under alien conditions. Mendeleev's table, written with paper and ink, now flies aboard satellites exploring other worlds. The rise of superheavy elements. Mendeleev predicted missing elements in his lifetime. Today, scientists continue that tradition. Modern researchers at laboratories like Dubna, Russia, Berkeley, USA, and Riken, Japan, have synthesized new elements. Element 113, nihonium, element 114, flerovium, element 118, oganesson. These elements exist only briefly fractions of seconds, but prove Mendeleev's table can stretch into the unknown. Every time a new element is confirmed, it completes a blank space he left more than 150 years ago. Conclusion. a world still guided by one table. From the inside of an atom to the farthest galaxies, from DNA to nuclear energy, from pollution cleanup to pharmaceutical design, the world of science still orbits the table that Dmitri Mendeleev built. But his true legacy is not just in data, in method. The belief that patterns exist, the courage to predict the unknown, the passion to unify knowledge. Every great scientist since has walked a path lit by his periodic light. Part 9. What if Mendeleev lived today? A creative exploration of Mendeleev in the 21st century. Reawakening in a new century. Imagine this. Dmitri Mendeleev opens his eyes not in 1907 St. Petersburg, but in a clean, quiet room in the year 2025. He sits up, brushes his long beard, and peers out a window. No horse-drawn carts, no gas lamps, only satellites streaking through the night sky, electric cars humming, and digital tablets glowing in human hands. Would he be confused? Likely. Overwhelmed? Certainly. But after the initial shock, one thing is certain. He would begin to ask questions. What are your units of mass now? Do the elements still obey my table? Has the ether finally been disproven? Can I see your atomic machines? Mendeleev's mind would re-engage, instantly curiosity, unchained by time. Tools of a new age. What he would embrace. Given access to today's technologies, Mendeleev would be unstoppable. Electron microscopes. He would finally see the atoms whose behavior he once predicted with pencil and cards. Supercomputers, capable of simulating molecules, reactions, and entire system stools that fit his need for modeling complex data. The Internet, a living library of global knowledge, free from gatekeeper sexactly, the kind of democratized science he long advocated. AI chemistry assistants, pattern recognition tools trained on millions of chemical reactions. Mendeleev would call them periodic oracles. 3D molecular visualization. He would marvel at seeing orbitals, energy levels, and crystal structures in dynamic, colored form. He wouldn't just use these tools, she'd reimagine how to use them. A new table, Mendeleev 2. If Mendeleev were alive today, he wouldn't merely admire the current periodic table, he would try to redesign it. He might group elements by quantum configuration, by functional role in biology, by technological relevance, batteries, superconductors, medicines, even by environmental risk. He would experiment with multidimensional tablescubes, spheres, hypergraphs combining mathematical symmetry with chemical reality. His original goal was always to reflect the truth of nature. Given modern data, he would build a table, not of weights, but of interconnections, tackling the grand challenges of our time. If given access to today's scientific agenda, where would Mendeleev focus? A renewable energy. He would dive into materials science investigating photovoltaic compounds, fuel cells, and ionic conductors. Every civilization depends on its energy of choice, he once wrote. Today, he'd fight to move beyond fossil fuels. B. Climate change. Understanding atmospheric chemistry, carbon capture, and sustainable synthesis would be core missions. Mendeleev loved the Earth's element. She would not watch them be poisoned. C. Artificial intelligence in science. He'd be fascinated, perhaps even wary of, machines mimicking the human ability to recognize patterns. But ultimately, he would treat AI as an extension of the scientific method. D. Space exploration, analyzing soil on Mars, elements on Europa, or materials on the Moon. He would help design a universal periodic system for space-based Elemensa cosmic table. Mendeleev the teacher in a digital world. Imagine Mendeleev teaching in 2025. His lectures streamed on YouTube to millions, his notes animated in VR, where students can walk among atoms. He'd create digital learning apps, blending logic puzzles with chemical reasoning, and yet even with all this tech, his classroom would remain simple. He would demand thinking over memorization, challenge students to discover patterns, not just facts, emphasize that science is not formulas, but relationships. The same man who once arranged elements with index cards would now design AI-powered flashcards, but never let them replace human intuition. In today's scientific community, would he fit in? Mendeleev would be both revered and controversial. Revered for his vision, historical significance, and data modeling. Controversial for his unorthodox predictions, his challenges to academic orthodoxy, and his insistence that science serve the people, not the elite. He would challenge grant systems, question overspecialization, and criticize scientists who chase fame more than truth. His fiery independence would earn both applause and resistance, just like in his own time. Collaborators and friends in the modern era, who would Mendeleev gravitate toward today? Bill Gates or Elon Musk? Perhaps for their obsession with innovation and systems, scientific activists fighting for open data? Almost certainly. Interdisciplinary research teams working across biology, materials, and computation? He'd be at the center. He would love TED Talks, Wikipedia, and global science festivals anywhere knowledge moved freely and rapidly. And he would collaborate globally, unhindered by borders or politics. Would he still be a visionary? Yes. In fact, in an age overwhelmed by information, Mendeleev's gift for pattern recognition would make him more valuable than ever. He'd predict new quantum materials, reorganize elements for AI chemistry, propose a mathematical unification of elemental traits. He would ask what few dare to. What comes after the periodic table? What is the structure of unknown knowledge? And then he'd go try to build it. Personal life in the 21st century, would he still be eccentric? Almost certainly. He'd wear a smart lab coat with chemical sensor patches, ride an electric bike with solar-powered flask holders, bring a barometer on airplanes, just as he once did on trains. He'd still be warm to students, but tough on lazy reasoning, still writing poetry in the margins of scientific papers, still teaching his children about the stars and atoms side by side. In this century, as in the last, Mendeleev would be a man of balance, passion and logic, discipline and imagination, solitude and service. A letter from Mendeleev, reimagined. Asterisk. To the future scientist, remember patterns are nature's whispers. Listen carefully. They speak not only of elements, but of ethics. Not only of structure, but of purpose. Let knowledge serve all people, not a few. Let wonder never be silenced by success. And when you feel the mystery ahead, do not fear it. Rearrange it like cards on a table, for even chaos is built on laws yet unseen. Dmitri Ivanovich Mendeleev. Conclusion: the timeless chemist. In a world of 3D printing, gene editing, and space probes, Dmitri Mendeleev would not seem out of place. He would accelerate, innovate, agitate, and elevate, for he was never a man of the 19th century. He was always a man of the future. Part 10, the final table. 150 plus elements, one vision, a journey through the modern periodic table. The modern table, still Mendeleev's at its core. When Dmitri Mendeleev laid out the periodic table in 1869, only 63 elements were known. Today, over 118 confirmed elements fill the grid with dozens of isotopes, variations, and synthetic compounds, expanding the field even further. Despite massive growth, the structure of the table remains faithful to Mendeleev's original vision. Elements still follow periodic transatomic radius, electronegativity, ionization, energy, and align in vertical columns, groups, and horizontal rows, periods, that tell a chemical story. Though scientists have refined it through quantum mechanics and added new elements at the edge, no other scientific chart has endured so long, so globally, or so usefully. Group 1. The alkali metals, the reactive pioneers. Elements: lithium, sodium, potassium, rubidium, cesium, francium. K uses: batteries, lithium, salt, sodium, fertilizers, potassium. These soft silver-colored metals are the most reactive of all metallic elements. They ignite in water, form strong bases, and are vital to human biology and global energy. Mendeleev correctly placed these elements in a group based on their extreme reactivity and +1 oxidation state. He predicted their weights and behaviors with uncanny accuracy. Today, lithium powers smartphones, while potassium helps crops grow, a testament to his predictive logic. Group 2. The alkaline earth metals. From bones to rockets. Elements: beryllium, magnesium, calcium, strontium, barium, radium. Key uses: alloys, fireworks, cancer treatment, radium, bone health, calcium. Mendeleev placed these together for their +2 charge and flame-coloring effects. In modern tech, magnesium alloys lighten spacecraft, and calcium ions guide nerve signals. Their trends in solubility and bonding still follow Mendeleev's predictions. These are earthy metals with heavenly uses. Groups 3-12. The transition metals, industrial giants. Includes iron, copper, zinc, gold, platinum, titanium, etc. Key uses: construction, electronics, catalysis, medicine. These D-block elements are known for multiple oxidation states and metallic versatility. Mendeleev was particularly fond of iron and platinum, calling them masters of transformation. Today, this section rules global infrastructure. Without them, there would be no bridges, cars, coins, computers, or clean energy. The lanthanides and actinides, rare earths and radioactive power. Lanthanides, used in lasers, magnets, TVs. Actinides, uranium, plutonium, nuclear energy, and weapons. Though unknown to Mendeleev in full, he anticipated their grouping by noting repeating heavy element traits. Their placement later, as a separate block beneath the main table, reflects the complexity he foresaw. Modern uses include MREI contrast agents, gadolinium, hybrid car batteries, neodymium, space probe fuel, plutonium 238. Group 13, the boron family, bridging metals and nonmetals, includes boron, aluminum, gallium, indium, thallium. Key uses: aircraft, cans, lead tech, solar panels. Mendeleev predicted the existence of gallium, eka aluminum, before it was found, even guessing its melting point and density. Today, aluminum alloys soar in aviation, and boron powers insulation and nanotech. This group balances reactivity and lightness, a sweet spot of science. Group 14. The carbon family, foundation of life and machines. Include carbon, silicon, germanium, tin, lead. Key uses: life, carbon, computers, silicon, semiconductors, solders. Carbon is the building block of biology. Silicon is the backbone of digital civilization. Tin and lead made up ancient coins and pipes. Mendeleev's prediction of germanium, eka-silicon, showed his brilliance described its properties a decade before it was discovered. This group connects biology, chemistry, electronics, and industry. Group 15, the nitrogen family, fertilizers, poisons, and DNA. Includes nitrogen, phosphorus, arsenic, antimony, bismuth. K uses: explosives, fertilizers, matches, semiconductors. Nitrogen sustains plant life and fuels bombs. Phosphorus glows in the dark and powers your DNA. Arsenic, once feared, now has medical uses in cancer therapy. Mendeleev predicted periodic jumps in toxicity and bonding patterns proven true by this diverse group. Group 16, the oxygen family, the breath of life, includes oxygen, sulfur, selenium, tellurium, polonium. Key uses: breathing, vulcanized rubber, solar cells, semiconductors. Oxygen is essential for respiration and combustion. Sulfur heals and burns. Tellurium and selenium are emerging stars in renewable energy. Mendeleev saw this group as nature's transformers compounds with explosive and healing powers alike. Group 17, the halogens, reactive and radiant, includes fluorine, chlorine, bromine, iodine, ostatine. Key uses: disinfection, toothpaste, photography, cancer scans. This group is deadly in pure form, but vital in small doses. Chlorine purifies water. Iodine prevents goiters. Fluorine strengthens teeth. Their -1 oxidation state and reactive nature made this one of Mendeleev's most clearly defined families. Today, halogens are in everything from pesticides to medical imaging. Group 18, the noble gases, the silent kings, includes helium, neon, argon, krypton, xenon, radon. Key uses: lighting, welding, space tech, medical imaging. These gases barely react, a mystery in Mendeleev's time. Helium wasn't discovered on Earth until after his death. It was first found in the Sun. Though he didn't live to include them, their placement in a new zero group aligned with his vision of periodic completeness. They now cool MRI machines, light up cities, and detect lung diseases. Their nobility lies in stability and silence. Beyond uranium, the frontier of super-heavy elements includes elements 93, 118, neptunium to oganesson. Key uses: still being studied, short-lived, synthetic. Each one fills a space Mendeleev left blank. Predicted by his periodic law, they were discovered only through nuclear engineering. Oganesson, element 118, closes the seventh period and marks the edge of known matter. What lies beyond? Mendeleev would say, leave room, nature is not yet finished. Isotopes and isomers, complexity within simplicity. Today, we know that elements have isotopesum protons, different neutron sand isomersum atoms, different structures. Mendeleev sensed this internal complexity, though he lacked atomic theory. Modern science now shows that each square on the table is a universe of subtle variation. This hidden dimension adds richness to medicine, energy, and archaeology. The table in culture. From art to politics. The periodic table now appears in art galleries, periodic sculptures, on political posters as metaphor for global unity, in movies like Breaking Bad or The Martian, in poetry and fashion. It has become a cultural icon, not just a scientific tool. It symbolizes structure, discovery, and elegance. The eighth period, what comes next? Scientists now theorize the possibility of an eighth period with elements that might form under extreme pressure or neutron flux, exist for only microseconds, behave unlike anything we've seen before. Some even predict an island of stability where superheavy atoms could last long enough to be studied in detail. The future of the table is still being written in labs, in space, in computers. Conclusion: 150 plus. Elements, uno, enduring vision. From hydrogen to oganesson, from life to lasers. From Mendeleev's notebook to Mars' reversed periodic table is a bridge from mystery to mastery. It remains his most lasting legacy, not because it never changed, but because it could change while still holding its structure. A map of matter, a mirror of logic, a monument to one man's vision. Part 11. Conclusion. The legacy of a visionary. Final reflections on the life and influence of Dmitri Mendeleev, the scientist who brought order to chaos. In a time when chemistry was an ever-growing list of unconnected facts, Mendeleev offered something no one else could: structure. He didn't just classify matter, he revealed its internal rhythm. His periodic table was not simply an arrangement, it was a revelation. He showed that nature, in all her complexity, speaks a language of patterns. And he taught the world to listen. A life forged in fire, guided by vision. Mendeleev's rise from the cold outpost of Tobolsk to the intellectual capitals of Europe is a story of resilience in the face of poverty and rejection, relentless inquiry that defied the norms of his time, rebellion against academic stagnation, romance and scandal, love and loss, a legacy of mentorship, teaching, and national service. He was not just a scientist, he was a builder of futures. He was Russia's scientific prophet. The ethics of discovery. One of Mendeleev's most enduring messages was that science must serve humanity. He fought for education reform, wrote public science texts, promoted clean energy, and warned of unregulated industry. His periodic law was built not for glory, but for clarity, for knowledge, and for human progress. In today's world of AI, climate crisis, and nuclear power, his words resonate louder than ever. Science must not become the servant of profit, nor the shield of dogma. It must be the voice of reason, the hand of compassion. Tributes that span the earth and sky. Mendeleev's name lives on across the globe. Mendeleev crater on the moon. Element 101. Mendeleevium, MD. Statues in universities, institutes, and even city parks. Curriculums in nearly every nation. UNESCO's International Year of the Periodic Table, 2019, in his honor, global awards, stamps, coins, and monuments. From Siberia to South Africa, from Tokyo to Toronto, his logic links us all. What the periodic table represents today, more than a list of elements, the periodic table has become a symbol of unity in science, a map of possibility, a testament to foresight, a challenge to future thinkers. It has entered classrooms, art galleries, fashion, and even pop music. It continues to expand, adapt, and evolve. Its origin may lie in 1869, but its relevance is eternal. Lessons from Mendeleev's life. From his journey, we draw 5 timeless lessons. Question everything. He doubted accepted weights, formulas, and even the table's own order to get closer to truth. See the unseen. He predicted elements before they existed, proving the power of inference. Serve society. He believed that science without humanity was hollow. Never settle. Even after global acclaim, he continued researching meteorology, economics, and philosophy. Unify knowledge. He saw all branches of science as threads in a single tapestry. Mendeleev and the dream of wholeness. Above all, Mendeleev was a unifier. He unified data into structure, ideas into laws, chaos into clarity, science into service. His periodic table was more than a chart, it was a manifesto. That knowledge is not infinite chaos, but ordered mystery, that the universe does not hide but whispers to those who listen deeply, that the most powerful tool in science is not the microscope or the lablet, the mind that sees connections, the eternal table. The periodic table is now a permanent feature of civilization. Like the wheel, the alphabet, and the calendar, it is a core technology of human thought. Its creator did not live to see its full power, but his vision lives in every young chemist's spark of discovery, every teacher's voice explaining groups and periods, every lab that studies elements and atoms, every effort to organize what once seemed unorganized. Dmitri Mendeleev is no longer just remembered, he is active in every moment science seeks meaning. One final word from Dmitri Mendeleev. Look deep into the laws of nature, and you will see harmony. Do not be afraid of confusion, follow the pattern. Truth is not hidden, it is waiting to be arranged. A legacy forever unfinished. Mendeleev would not want a final chapter. His work invites us to continue, to question, to discover, to organize, to dream. The periodic table will grow. The elements will change, but the law that vision, courage, and reason can bring order to the universe will endure, just like the name Dmitri Ivanovich Mendeleev. Part 12. Philosopher of Patterns. Mendeleev's vision beyond chemistry. Science as a moral endeavor. To Mendeleev, science was never just a collection of facts or theories. It was a moral responsibility. He believed that the pursuit of truth had to be aligned with the pursuit of good. He once said, science must serve not only the intellect, but the soul of man. In Mendeleev's view, a scientist was a custodian of knowledge, tasked with not only discovering how the world works, but applying that understanding with wisdom, humility, and for the public benefit. This ethical framework made him stand out, even among his contemporaries, many of whom focused solely on experimental achievement. The unity of natural law, central to Mendeleev's worldview, was the conviction that nature is unified. His periodic law was merely one expression of this principle. He believed that if one looked hard enough, patterns would emerge across every scientific discipline. He wrote, there is no border between the sky and the soil. The law of the elements must also govern the law of the stars. This belief guided his attempts to find unifying principles between chemistry, physics, meteorology, and even economics. He saw fragmentation of knowledge as a temporary limitation, not a permanent condition. Today, such views align with the modern pursuit of unified theories, frameworks that connect quantum physics, chemistry, biology, and information science. In this regard, Mendeleev was not merely ahead of his time, he was building the foundation of a vision that future generations are still attempting to fulfill. The soul of a system builder. What made Mendeleev unique wasn't just his ability to observe, but his compulsion to organize. Like Newton, he believed that understanding lay not in memorizing data, but in recognizing systems of relationships. In his private journals, he would often sketch diagram serows, branches, spirals connecting concepts across domains. These weren't just scientific notes, they were visual manifestations of his internal logic. One page might begin with a list of known elements and end with speculations about planetary orbits, economic structures, and psychological typologies. Mendeleev was not just categorizing atoms, she was mapping the architecture of thought itself, teaching the young. The mind as a garden. Mendeleev saw education not as a rigid process of transferring information, but as a dynamic act of cultivation. In one of his lesser-known lectures on pedagogy, he likened the mind of a student to a garden. Plant a question, not an answer. Water it with patience. Expose it to the light of evidence. Let it grow wild before trimming it to clarity. He argued that questions were more important than answers, and that the role of a teacher was not to command, but to provoke, to stimulate, and to empower. He criticized rote memorization and outdated syllabi. In its place, he advocated for curricula grounded in pattern recognition, practical application, and moral relevance. The ethics of prediction. Few scientists dared to make bold, testable predictions like Mendeleev. Yet he never saw prediction as a gamble. To him, it was a moral obligation, an act of faith in the order of the universe. His predictions were not magical. They were the result of logical gaps and unwavering belief that no law is incomplete if it's real. When gallium, scandium, and germanium were discovered precisely as he had forecast, he felt not pride, but relief. Asterisk. It is not I who is right, asterisk, he wrote. Asterisk. It is the law that revealed itself to me. Asterisk. This humility in discovery reflected a rare fusion of scientific rigor and philosophical modesty. Silence, solitude, and insight. Unlike many public intellectuals of his time, Mendeleev retreated often into solitude. Asterisk. Asterisk. His most productive periods were during personal withdrawal, when he wandered the countryside, stared into firelight, or walked for hours with nothing but a notebook. He believed that silence was a condition of insight. Asterisk. Asterisk. That to hear the rhythm of nature, one had to quiet the noise of ego, acclaim, and even ambition. Modern creativity research supports this. Breakthroughs often occur not during action, but reflection. In this, Mendeleev was not just a scientist, was a contemplative thinker, a seeker of stillness. On the limits of human knowledge, despite his love for system building, Mendeleev was acutely aware of the limits of knowledge. Asterisk, asterisk. In the final volume of his Principles of Chemistry, he added a rare philosophical chapter entitled Asterisk, the Unknown. Asterisk, there he wrote, asterisk, we must not mistake our maps for the territory. To know some things is not to know all things. To recognize a law is not to master its cause. Asterisk, he acknowledged that mystery was not failure, but the companion of truth. In our modern era where science often veers toward arrogance or nihilism, Mendeleev's stance offers a rare and needed middle path. Awe without superstition, reason without absolutism. Chemistry as cosmology. Mendeleev's cosmic vision of the periodic table foreshadowed what would later be discovered in astrophysics and planetary science. He believed that the organization of atoms was a clue to the architecture of the universe. Asterisk, asterisk. He imagined stars, planets, and life all governed by the same elemental relationships. His private notes include speculations about elemental frequencies in galaxies, elemental decay and stellar evolution, and even chemical echoes of the Big Bang, a concept not named until decades later. To Mendeleev, the periodic table was not just a scientific tool, it was a cosmological compass. The alchemy of modern science, though Mendeleev rejected traditional alchemy, he admired its spiritual hunger for transformation. He believed that real science should never mock the past, but redeem it. Asterisk, asterisk. In this way, he saw himself as a modern alchemist, not seeking gold, but seeking understanding. Asterisk, asterisk. He turned the dreams of mystical transmutation into real nuclear chemistry. He turned symbols into structures. He turned chaos into pattern. And in so doing, he proved that the human spirit could not only study nature, but harmonize with it. His final message to the modern world. If Mendeleev could speak to today's scientists, politicians, and students, his message might be this: asterisk, seek pattern, but respect the wild. Use knowledge, but never hoard it. Question, even what you have proven. Protect the earth, for it is made of the very elements you study. And above all, never forget, the world is beautiful because it is ordered, and mysterious because it is not yet fully known. Asterisk,